Limiting reactant and yield calculations. In many chemical processes, the quantities of the reactant used are such that one reactant is in excess and the other one is present in the smaller amount. The amount of the product formed in this case is depends on the reactant that is not in excess, and this reactant is called the limiting reactant. That means it limits the amount of product that can be formed. For example, let's say we have these two reactants. This is reactant A and this is reactant B. These are, let's say, bread slices and these are cheese slices. And I want to make, so these are my reactants, and what I want to do is I want to make the sandwich. And what is my sandwich made up of? Two slices of bread and one cheese. So I use these two slices of bread and this piece of cheese and I made my one sandwich. Then I can use again these two slices and with this cheese slice and I have my another sandwich. Now can I make any more sandwich? No. Why not? Because even though I still have slices of bread, but I do not have cheese, slice of cheese. So that means this, the slices of bread, this is my limiting reactant. And what is this? This is an excess reactant which is left once the reaction is over. And what are my products here, or what is my product here? These sandwiches. So limiting reactants limit the amount of the product that can be formed. Means if I want to make more product, I cannot make it because this reactant is gone. Now, how this was general example. Then how do we find out the limiting reactant in a reaction? First, you calculate the amount of product formed from each reactant. Like we saw in the previous slide, I'm making the product, I was making the sandwiches. So now that amount of product that you're calculating can be in moles or grams. And then determine the limiting reactant by selecting the one that gives the least amount of product. So, and this is also known as theoretical yield. Let me explain you with this question. This is your reaction, manganese dioxide reacting with hydrochloric acid. Let me say it again, 1 mole of manganese dioxide reacting with 4 moles of HCl to form 1 mole of manganese chloride, 2 moles of water and 1 mole of chlorine gas. The question is, which is the limiting reactant when 3 moles of manganese oxide are reacted with 10 moles of HCl in the following reaction. So we have to find out of manganese dioxide and manganese oxide, and HCl, which one is the limiting reactant. So what you're going to do is you can pick any product out of these three. Let's say I'm going to pick the first one. Starting with 3 moles of manganese dioxide, you're going to find how much manganese chloride, how much this product can be made. So starting with 3 moles of manganese dioxide, we're going to see how much manganese chloride can be formed. So we want manganese oxide here and moles of manganese chloride here. And look at this ratio. 1 mole of manganese oxide is producing 1 mole of the manganese chloride. This cancels out, and so we have 3 moles of manganese chloride. Now similarly, we're going to do, starting with 10 moles of HCl, we're going to see how much manganese chloride I can make. And I can see that 1 mole of manganese dioxide is producing, this is 10 moles of HCl. So moles of HCl here and moles of manganese chloride here. You compare with the same product, and we have 4 moles of HCl producing 1 mole of manganese. We have 4 in front of HCl and 1 in front of this. And what is 10 divided by 4? 2.5 moles of manganese chloride. Now then you see, where are you getting the less amount of product? Here you're getting 3 moles of the product, here you're getting 2.5 moles of the product. So the less amount is here. That means you're getting the less amount when you're starting with HCl. So HCl is your limiting reactant. So the one which is not the limiting reactant in the reaction, that's an excess reactant, means that will be left after the reaction is over. Then how do you find out the amount which is left of the excess reactant? For that, what you do, you calculate the amount of the other reactant needed to react with the limiting reactant and then subtract this amount from the original amount. Let's look at this question. How many grams of excess reactant remain unreacted when solution contains 50 grams of magnesium bromide and 100 grams of silver nitrate are mixed together? Now this is the reaction. Magnesium bromide, 1 mole of magnesium bromide reacts with 2 moles of silver nitrate to form 2 moles of silver bromide and 1 mole of magnesium nitrate. Now, first in this question, you're going to find out which one is your limiting reactant, and then you're going to follow exactly the method that I told you in the previous slide. But make sure first convert these 50 grams of magnesium chloride, bromide and 100 grams of silver nitrate to moles first, and then from moles to moles. And when you're going to do that, you will see that magnesium bromide will be your limiting reagent. So now we know which magnesium bromide is a limiting reagent, silver nitrate is excess. Now the question is, after the reaction is over, how much of this excess reactant is left? So what you have to do is follow the step 1, calculate the amount of the other reactant needed to react with the limiting reactant. Means how much silver nitrate is needed to react with 50 grams of magnesium bromide. So you start with 50 grams of magnesium bromide. You change grams of magnesium bromide to moles of magnesium bromide by using molar mass of magnesium bromide. Then you go from moles of magnesium bromide to moles of silver nitrate, which is your excess reactant. And then you convert these moles of silver nitrate to grams of silver nitrate by using molar mass of silver nitrate. And then you will get 92.3 grams. What does this 92.3 grams means? That in the reaction, 92.3 grams of silver nitrate is reacting with 50 grams of magnesium bromide. Then how much is left? We started with 100 grams. We used 92.3 grams to react with magnesium bromide. Then how much is left? 7.7 grams. How to calculate the percent yield of a reaction? The formula is the actual yield. The actual yield is which you get it by doing the experiment, and the theoretical yield is which you get it by seeing how much product you're getting starting with the limiting reactant. So the product, the amount of product formed from the limiting reactant is the theoretical yield. So that's theoretical yield is not experimental, it's the one you should get. And actual yield will always be given to you in the exam because it's by the experiment. So if you have a question, calculate the percent yield for the following reaction if 233 grams of nitrogen dioxide reacted and 175 gram of nitric acid was formed. So when they did the experiment in the lab, they got 175 grams of nitric acid, which means 175 grams is the actual yield, the experimental yield. How much is the theoretical yield? Now to find out the theoretical yield, yes, we do have to find out the limiting reactant, but in this question, since they did not give you the amount of water, they just gave you the amount of nitrogen dioxide, that means we're going to assume that this is the limiting reagent. Then we're going to find out, starting with 233 grams of nitrogen dioxide, how much nitric acid can be formed, and that we have to find out in grams because The actual yield is given in grams. So starting with 233 grams of nitrogen dioxide, we are changing grams of nitrogen dioxide to moles of nitrogen dioxide by using the molar mass of nitrogen dioxide. Nitrogen is 14, oxygen is 16. 16 times 2, 32 plus 14 is 46. Then you go from moles of nitrogen dioxide to moles of nitric acid. And where do you find this ratio? In your balanced chemical equation. 3 in front of NO2, 2 in front of nitric acid. And then you convert these moles of nitric acid to grams of nitric acid, and 1 mole of nitric acid equals to how many grams? Hydrogen is 1, nitrogen is 14, 16 times 3 is 48, and that comes out 63. And when you do that, you get 213 grams. So what it means then, ideally speaking, from this reaction, you should get 213 grams of the product nitric acid. But what is the percent yield? So percent yield is actual yield, which was 175, divided by 213, which is a theoretical yield, times 100 to change it in the percentage. So the percent yield is 82.2%.
Made with DoodleCast Pro.